So we've probably all heard of black holes before. Infinitesimally small concentrations of mass in space that absorb anything that gets too close to them. But did you know there exist such things as supermassive black holes? No, really. It's not just a Muse song. Dr. Martin Krause has been telling me that there is much more to them than that.
So we know two kinds of black holes. We call them stellar mass black holes and supermassive black holes. The stellar massive black holes, we have a good idea how they come about. So when a star that's about 10 times the mass of the Sun comes to the end of its life, it just collapses and forms these black holes, maybe 3 times the mass of the Sun, maybe 10 times. And then in the centers of galaxies, we have this evidence for a lot of mass in a very small space that produces huge amount of energy. And so the mass that you need is at least 1 million times the mass of the Sun. So these are very different beasts that we have no clue how they come about. We see usually one in the center of each galaxy. Not every galaxy, but many galaxies.
Because they trap everything that gets too close, they're impossible to detect directly. You have to look for the effects they cause. One of the things you can look out for are jets. No, not those. What we're talking about is a jet that's blasted out from matter surrounding a small percentage of supermassive black holes by magnetic fields generated as matter is consumed. These jets then generate radio waves as they pass through the cosmos. But what are these jets?
They consist of elementary particles. We know there are electrons because the electrons is what actually produces the observable radio emission. It's not quite clear if they also consist of protons or maybe they consist of electrons and positrons, which are the antiparticles of electrons. So elementary particles that move at very high speeds. They are seen since about the 1950s, since we have radio astronomy. They are the most prominent things on the radio skies. So the way they interact with the gas around them produces particular shapes. If they run into a dense cloud, it looks different than if they just plow through some very tenuous gas.
What's the longest jet we've ever observed?
It's about 12 million light years.
Wow, that is colossally large. It sort of boggles the mind to try to think about how large that actually is.
Perhaps I should compare it to from our Sun to the center of the Milky Way. It's about 25,000 light years. Our Milky Way galaxy is about 100,000 light years in diameter in total. A cluster of galaxies is about 10-ish millions of light years, and the jets we see are comparable to these biggest structures that we actually know.
So how do these jets help us know whether there is just one black hole or two orbiting close together? Dr. Krause says it's all about the wobble.
If you have a companion to a black hole that emits a jet, it causes the jet to wobble about. So it changes its direction periodically. So then I took a sample of jet sources and looked at them from the perspective how many of them could be explained with a changing direction. And it was actually very surprising. So when you look at it with that question, quite a few of them have very obviously this, we call it precession, going on. And if you do it systematically and compare it to computer simulation, we found actually that 75% of them show this. And this was really a surprise to me.
If there's one thing that you wanted people to remember or take away from the paper, what would that be?
I'm quite excited that we get closer and closer to finally learn what supermassive black holes are. So they've been postulated to exist in the 70s. Looking at the jets, we have learned how much energy they can produce. We hope to learn more about their characteristics. I'm really looking forward to future detections of supermassive black hole mergers. I very much hope we're going to find something, and I'm really confident that we will, actually.
And I guess this has given us a way to know what areas of space we're looking at with any detection methods that might come up in the future, because we've seen things that we're fairly confident should be binary black holes.
That's absolutely right. If you know where things are, it's easier to look.
That was Dr. Martin Krauser from the University of Hertfordshire talking to me, Sam Brown, about the paper published in the monthly notices of the Royal Astronomical Society.